Today we are going to tackle the house robber problem on LeetCode. It's the problem number 198, which has the medium difficulty. And if you watched our last video on dynamic programming where we solved the Fibonacci sequence problem, this is going to build on those concepts. So let's start first by let's first go through the problem description. So you are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if the adjacent houses were broken into on the same night. Given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. So let's quickly go through a few examples. So example 1, the input array is called nums, and it contains the houses that have 1, 2, 3 and 1 amount of money each, and the output should be 4 in this case. Why 4? Because we can rob house 1 with money 1, and then we can rob house 3 with money 3 with 3 amount of money. So 3 plus 1 is 4, and that's actually the maximum value you can get from this input array by following the rules that are described here. So why is that the case? So if we choose house 2, second house, first, to rob a second house first, and then we can't take the money from the third house because it's adjacent to the second one, and we can do it from the fourth house. So 1 plus 2 is 3, which is less than 4. So indeed, the maximum amount of money you can get from these houses is 4 by taking the money from the house 1 and house 3. In the second example, the provided array contains the following amounts: 2, 7, 9, 3, 1, and the output should be 12 in this case. Why 12? So we can rob the house number 1, and then house number 3, and then house number 5. And in this case, the total amount of money we can get is 12, which is equal to 2 plus 9 plus 1, which is 12, and that should be the outcome of this second example. Please note that these amounts here are non-negative values, so we can assume that there will be no negative values here. And also, we can also assume that this provided input array is never going to be null nor have the nor empty, basically. So how we can solve this problem using the dynamic programming approach? Please check out the previous video if you want to learn more about some general concept how dynamic programming works. But to solve today's problem, we will be using the bottom-up approach of the dynamic programming. So we will try to find smaller problems first, to solve them, and to build up the overall solution using the solutions from these that we calculated by solving these smaller problems. So that's how we are going to solve today's problem. So here we have to implement the method called rob, which takes an input array, an integer array as an input, and which returns an integer which represents the maximum amount of money we can get from the provided houses. So nums of I represents the amount of money in the house indexed with I, so in I plus 1th house, basically. So let's quickly write this second example down So 27931, 27931. So this is an example input, and instead of calling these houses first, second, third, etc., maybe we can call them by their indexes in the array. So those indexes will be 0, 1, 2, 3, and 4. So this would be the house. So the first house will be, we can call it house 0. The fifth house will be house 4, etc. Also, as you have noticed, and as always, I will be solving the problem using Java programming language. But yeah, it should be quite straightforward to transform this solution to any other programming language. So how can we solve the problem? Using the bottom-up DP approach. So the bottom-up DP approach means that we need to figure out to find smaller problems and how we can define a smaller problem here. So we can denote with dp of I, where I is a number between 0 and n minus 1, and also where n is the length of the provided array, nums length. Okay. With dp of I, we can call the maximum amount of money we can get from the sub-array of the provided array that ends in the house indexed at indexed I. So it would be the maximum amount of money from the array indexed of 0 to I. And let's say that we know this solution, that we know or what should be, how can we use, let's say that we know the solution for the smaller i's. Let's say that we know that what dp of I minus 1 is and dp of I minus 2 is. Let's say we know these values. What should be this, the solution of dp of I? So let's say that I is 3, and we know that the solution for dp of 1 and 2, so for 1 would be, let's say, 7, for 2 would be 9 plus 2 is 11. So if we extend this sub-array with the house indexed at with the fourth house, basically index 3, what should be the solution of that subproblem? Well, the solution would be either the solution of the sub-array that ends in the previous house, or the solution of the sub-array that ends in dp of in I minus 2 plus the amount of money in the house 3. Why is that the case? So we can write this down. So dp of I would be the maximum value of dp of I minus 1 and dp of I minus 2 plus nums of I. Why is this the case? Well, because if we take the the value of dp of I minus 1, given that these are non-negative numbers, given that I minus 1 is adjacent to I, so we can't rob the house I if we take the value that ends here. But if we take the value that ends of the sub-array that ends in I minus 2, then we can take all of that money, and on top of that we can add the money from the house I, because it's not adjacent to I minus 2 house. this works only because these are non-negative numbers. So if we can, whatever we can take from the first from the houses 0, 1, 2 all the way to I minus 2, we can safely add the money from the house I, because it's not adjacent, it's not negative number, so it can only increase the overall solution. And basically this is it. To solve the problem, we will keep track of all i's, and let's see what will be the starting point. So dp of 0 should be nums of 0. So if we take only first element, the subarray that contains only the first house, well, the solution of that subarray is definitely to take the money from that house, because there are no other houses, so we can take it, and given that it's a non-negative number, we can take whatever amount of money is in that first house. What would be the dp of 1, sorry, dp of 1? Well, let's take the first two houses. So given that they are adjacent, so we can't take money from both houses, but we need to choose one of them. So which one we will choose? We're going to choose the house that has more money, right? So it should be the maximum value of the provided amount of money in the two houses. So it should be the max of dp of 0 and dp of 1. Okay? And then for every next dp of 2, 3, 4 all the way to n minus 1, we can use this formula to calculate it. The overall solution of the problem will be dp of n minus 1, so the last element. And that's it. That's the solution of this problem. So let's try to implement it now. So we're going to need an additional array called dp, which is an array of integers, and which will have the n number, which will be the length of n, where n is the length of the provided nums array. Okay? And we can say, before we start, we can first check if nums, okay, we can assume that nums is not a null value or it's not empty, and we can assume that the provided elements are non-negative. But if you want, you can add that validation as well. It's always good to, as I always say, it's always good to clarify that with the interviewer if you're given this problem during your interview. So please make sure to at least mention this check, so they are aware that so we are sure that I'm sorry. So please make sure to check, to clarify this with the interviewer, to make sure that we are aware of these constraints. And if they say they are fine not to add these validations, you can simply check it. I can add some of them. So let's say if nums is null or nums.len is 0, we can return 0 in that case. So there are no houses, and therefore no money, okay, to be taken. Okay, so that's the first check, and then we need to check two more things. So for these edge cases, when there is one house and when there are two houses. So if nums.length is 1, then we can simply return whatever amount of money is in that single house. Nums of 0. If nums.length is 2, then we need to return the maximum of the two amounts. So we can return, in Java we can write something like this: math. There is this helper class math that has a max method that will take the maximum of the two provided values, that will return the maximum of the two provided values. So it will be nums of 0 and nums of 1. But if it's not null, if it's not empty, if it has a the length greater than 2, we can apply the dynamic programming approach. So DP is a helper structure that will be used here, which has the length of n, and we can say the DP of 0 is nums of 0, DP of 1 is the maximum of the two, max nums of 0, nums of 1. Okay, and now we need to calculate the solutions of every single sub problem. So DP of 2, 3, 4, all the way to the last element. So for int I equal to 2, while I is less than nums.length I plus plus, and we can say that dp of I is equal to maximum value between dp of I minus 1 and dp of I minus 2 plus nums of I. And that's it. The solution of the problem would be dp of nums.length minus 1. And that's it. That should be the solution of this problem. We're going to test this solution shortly. Let's just quickly go again through this formula here. So the maximum amount of money we can get if the input array has only one element is to take whatever amount of money is provided in that house. If there are two houses, we can't take from both of them, but we will take the money, all the money from the house that has more money, because they are adjacent to each other, so we can't take the money from both houses. But if there are more than two houses, so let's say there are three houses, so then we will use this formula to take the money from the second house, or from the first house plus from the third house. So let's say that the input array has the following values: 1, 10, 5. dp of 0 would be 1, dp of 1 would be 10, because 10 is greater than 1. But dp of 2 would be greater value from dp of 1, which is 10, or of 0 plus this amount 5, so 1 plus 5 is 6, so because 10 is greater than 6, so it will again be dp of I minus 1. So dp values in this case would be 1, 10, 10, and the solution would be 10. So we can simply take the money from the second house. That's more money than from the first and third house combined. That's why we decided to take it from the second house. Okay, and let's test this solution. So let's use these values. So int nums is equal to is a new int of these values. Okay, and so as always the method rob is placed in the class called solution, so I need to create an object solution equal to new solution, and let's print the result out. So system.println result is solution.rob nums. Okay, and the solution in this case is 12. So this is the correct solution by taking the money from the houses with from the first, third and fifth house. 2 plus 9 plus 1 is 12, and that's why the solution in this case is 12. So this is the optimal solution as well. So let's just quickly go through the time complexity of the solution and through the space complexity as well, because I feel like this solution can be optimized when it comes to the space complexity. So the time complexity of the solution would be, so here this check takes constant amount of instructions, this check as well, this check as well. So calculating the maximum value between the two values also takes constant amount of time. Here we are initiating an array with a length of n, and this also takes the constant amount of time, lines 41, 42, and here we are iterating through the whole array to calculate the values of this in array dp. So overall here we have the linear time complexity. So the time complexity of this problem is driven mainly by the length of this array nums. So it would be big O of n or nums.length. So we can say that this problem has the linear time complexity. On the other hand, what would be the space complexity of this particular solution? Well, the space complexity would be also linear. Why? Because we have created here an additional array with a length of n. So the space complexity would also be big O of nums.length. Basically it would be dp.length, but dp.length is equal to nums.length, so we can say that it has linear space complexity as well. So the solution has the optimal time complexity, but the space complexity can be improved. I'm not going to do it here because I leave it to you, but just to give you a hint, anytime we are calculating dp of I, we are not considering we are only considering the previous two sub-problems solutions. Having said that, we don't need to keep track of the all sub-problem solutions, but only of the last two. Something similar to the bottom up approach in the previous video of the when we were solving the Fibonacci sequence problem. So that's why this can be optimized. This dp array can be eliminated, and we can only keep track of the last two sub-problem solutions. But as I said, I'll leave it to you. It should be a straightforward change. I hope that you like this video, and in the next video we will continue solving problems using the same dp approach. We'll probably try to solve a more challenging problem next time. Thank you.